Hello there. Well, today we're going to do a set which is one of mine. It's an Amstrad 901 genuine, so it's a Cybernet 002F made in Japan, and we're going to sell this. I've got about 4 of the genuine Amstrads which can be sold on. 19th of November 2025, and these are usually exceptionally good performance. It's R49046. This will go out with a new power lead, and let's hope there is some kind of power lead on here in order for me to plug this in. Otherwise it's borrowing one from stock. Right, it looks like that's what we're doing. Yeah. Right, we'll come back to that. I'll open this up first. Now, these have been bought in over years. I mean, I could have bought this in 20 years ago. It could have been donated to the channel. We don't keep track of that kind of thing these days. It's got a screw missing. But because it's an unknown, I just need to open it up to make sure there's no shenanigans going on. And this one is better than usual case for the. Still got the plastic on the back. And you can see it's a square round type of connector, not the really early one. Remember, the only Amstrad thing about these is the name on it. These are a Cybernet radio. It just happens to say Amstrad on it. Okay, so what silliness is this? It's a bit worrying, isn't it? Why is that so dark? Anyway, I can't see any shenanigans. So usual thing, if we can't get 3.6 watts out of it, we'll change the ballast resistor. This type usually we can get somewhere near. Very good audio on these. Very sensitive receivers. So I can see some soldering around the output transistor. But it is the right one, I think. No, it isn't. So it should be a Mitsubishi 2SC2166. This has got Billy No Mate's 2SC2078 in it. That's not the right transistor. So that immediately is a snag, because those transistors are about £16. And one of the problems is you've got the people with the silly modifications shorting out the ballast resistor, which makes it do 7 watts, but not on, I've shown this before, not on 27 megs. You get 2 watts on 27 megs and 4 watts on aircraft band. So on a cheap power meter like Zitagi do, it'll say 7 watts. You put it on a selective power meter, something like a Bird 43 through line, or with our test set here, and it will show less watts, but put it into a spectrum analyzer and you'll see where all the watts have gone. So that's going to be interesting, because that's going to put a huge snag if we've got to start trying to get a 2SC2166 from somewhere. All those ones on eBay, or nearly all the ones on eBay, unless they really are old stock, anything that looks nice and shiny is going to be fake. And why is that? Because they stopped making them in 2001. So the fact is, they're all going to have tarnished legs. So anything that looks really straight out of the factory is going to be fake. So, wonder why it had to have the output transistor changed in the first place. Do we think that at some point it was on a bad SWR? Anyway, we'll plug in our standard replacement mic. Did I say I've got 10 minutes? Dinner's cooking. I'm going to go and get a power lead. Right, get that plugged in and connected to our crocodile clips. And we'll connect our speaker on the wall to public address, which is that socket, and we will switch on. Make sure we're in CB, in PA. Testing 1 2, testing 1 2, testing 1 2 1 2. Got a noisy volume control. So we'll switch to power off on the power supply. We'll deal with that immediately. If things like this have ever been in a smoking environment, it really is a problem with the potentiometers. Right, let's power it back up again. Testing 1 2, testing 1 2, testing 1 2. That's nice and smooth. So we'll get our clipboard. So PA works, and volume control cleaned. Right, we'll change that over to the CB socket, switch it over to CB. And why have we got a dry joint? It came up perfectly and then it's dropped off. I've switched it back on again. Right. Well, it's certainly receiving at 0.3 of a microvolt, but we'll do that in a moment. So my concern with this, to put picture in picture on, is the transmit. And what have we got? Well, in actual fact, we've got 3.8 watts, so there we go. I wasn't expecting that. So a genuine wrong transistor, which is fine, but capable of... it's capable of less power, but the 2SC2166 isn't going to give you more power. Right. We'll probably change that ballast resistor. I just don't know why it's got the darkening. Right, let's go through the transmit then. So, we've got... It's warmed up a bit. It's 3.7 watts. It's 3.55 watts. It's 3.7 watts. Back to channel 20. Turn the volume down. Power consumption is 1.439. I think that's high, but there we go. Only a little bit high because these sets draw more current than the Cybernet 134. Stick it on low power, and we've got 270 milliwatts, which isn't adjustable. Deviation. Wow, oh my goodness. I bet that sounded good on the air. Roger. Wallow. So with there, it's 10, 15, wallow. 16 kilohertz. So just transmit on 3 channels at once, why don't you? (2779100), which is okay anyway, but of course it should be 2779125. Let's see whether that comes up straight away. Anything more than that is a bonus. Let's go on to the frequency counter so you can see what I'm doing. Mice haven't been kind to that overnight. This one's spot on. We've got VCO notes on this, is the question, and do we have to print off again, as usual? Of course we do. Oh, right. So we'll come back to VCO, just go through the transmitter, and I'll go for lunch. Let's go back to the main meter, which isn't quite where it should be. So have I got the right tool there? I want the 1.5, which is that one. So we want absolute peak. We're still on low power. Yeah. I'm going to change that ballast resistor anyway, so I'm going to curtail that. We'll go for lunch and I'll do that when we get back. Okay, so if we rejoin this, just check the tightness of all these mounting screws. We don't want microphony. Put a different ballast resistor and we'll clean around there with isopropyl alcohol where they changed the transistor. We're looking into this transistor, but first of all I'm just going to do the tune-up on transmit. So I've got the nice new expensive 7-watt resistor in there, so at least you've got a cat in hell's chance of getting a decent 4 watts. And basically the 2166 transistor which they normally have in these is a 12 volt transistor. And we've not got any power. Why is that? Because I'm pulled these off the... I have. I think I've gone round in a complete circle with the... with how I've had the radio. Twisted it in a complete circle. There we go. Right, let's have another look. So now we've done no more tuning. If you remember, we just did those, and we'll see whether we're a bit nearer 4 watts. We're over 4 watts. Well, that figures, doesn't it? These are 3 ohms. Okay, so where did I put the tool? Put the radio on top of the trimming tool. Okay, so recheck this one. That's centre of peak. Just need to loosen the wax on that one. Loosen the wax a bit more on that one. It's quite cold in here. We're in November. I doubt the temperature is much above 12 degrees. And then that one, and we set the power with this one, and we're tuning downwards for 4 watts, because just over we're tuning downwards, not upwards, downwards. Okay, so that's channel 20. Let's check channel 40. We've got 3.95 watts. Channel 1 we've got 4.0. That'll do. So I'll drop that down. We'll do the VCO. So it's ballast resistor, 6 watt type. So it's 4.05 watts, 4 watts, 3.95 watts. The transmit current will be probably scarier. 1.36. It isn't, you see. So we've got that 0.3 of a watt. We've got that third of a watt more, and our current consumption has come down the best part of 100 milliamps, just because we've tuned it right. What our low power will be is anybody's guess. Let's have a look. Well, in actual fact, it's 320 milliwatts, so that's headed in the right direction. Remember, it's supposed to be 400 milliwatts, according to the government specification. So, our other test set is on. We'll do the deviation, and I'll set it on here initially because it's just stupid. Oh, look at it, it's at full. I mean, how can anybody be so daft? It's really going to make it work better. The only thing that's going to sound louder to is a Fidelity 1000. Wow. Now, that, according to this test set, that's spot on, but we'll just go to the other test set, which doesn't have deviation meter capacitor issues. Quick look. I can just give it a fraction more. Expecting, have these got mic gain? No. Just give it that little fraction more. That's kind of peaking at 2.3. This fine balance of being quiet, or the right volume, or over deviating so that it sounds dreadful on anything with any selectivity. Wow, that's it. So we've got 2.2 to 2.5 kilohertz. We're going to do the VCO. And we need the multimeter for that. I've got a nice Heathkit bench multimeter, but the trouble is I want the overhead camera to see the, otherwise we'll need even more cameras, and I can't put any more cameras on the system we've got. So this is a good reason to use. I would like to use the Heathkit one, but I could also use the Keithley one, but that'd be showing off, and we don't do that. Right, where we're going to pick up our ground from, one of these coils. Why not? Let's put it on one of these receive coils. So the far side of this capacitor, we need, I think it's channel 1. We're going to look at the instructions right now. Every time I do one of these I have to print this off because I've got a memory like a sieve. So it's channel 1, capacitor 9, and adjust for 2 volts. So you do receive first. It's 2.25. Now that's pretty close, but I don't know if you can see, I'm doing this coil here. I mean, it doesn't really need adjusting, it's absolutely near enough, but we'll leave it at that 2.06. Now we're going to transmit. What do they want? About the same, I think. I'm not going to adjust that unless it's out on channel 40. It's the trimmer capacitor for transmit. It's so close. So close. Yeah, 3.6. And what was it on transmit? I forgot to note it in my little brain. 3.7. So that's the VCO done. So that's something on this which wasn't really out. But I have just trimmed it back that little fraction. So it's supposed to be, it's 2 plus 2.1, wasn't it? And it was 2.3 plus 2.1. Look at the transmit meter. Especially if we really are. Have I got a Duff Crocodile clip here? Right, so back to channel 20. Well, here's where we need to set this. So it's going to be a full set of bars. I put it on low power, and what they want is it for it to be 1 bar on low power. I noticed that's set to full, but you see it's set to, so it's doing 3. We don't want that, so it's set to 1. So now when we go to full power, it should be all 4. Well, I don't want it to be quite all 4. I don't want it to be all 4. I want it to be just starting to light the plus 30. Just. And then, if there's any anomaly with the SWR on your aerial, you'll see it, because you'll get to know when you put this on your aerial where this radio is normally. Remember, it's only going to give the correct power level on that meter when it's on a dummy load. When you put it on an aerial, it'll read something else. It might read 3, it might read 5. It doesn't mean you're doing more or less power, because it's relative to the SWR. And this is what my gripe is with modern sets. They've got rid of that confusion by pre-programming the meter off the CPU to just read what they want it to read. It does no more than a transmit light. You can take the output transistors out, and modern radios will still say it's doing the power it says it does, which is BS, and I hate that kind of thing. So it was reading 5, it's now reading 4. I should really put full scale deflection, which is what it was reading. Before we start messing with the receiver, let's see where. I'll tell you what, we'll just finish the frequency off, because it was everything was still warming up before. So we'll just go over to camera 2, which is nearly where we want it, and we'll just trim, if we need to. 2770, it's just slightly high now, so we'll drop that. To 7. There we go. Switch the deviation meter on. Sorry, the SINAD meter on. Switch the oscilloscope on. We'll put the receive now on the correct frequency of 27.79125. I've just remembered I need to do some online banking, or something might not get paid today. I've got to do some robbing Peter to pay Paul. Let's just look at where we were with the receive, RF gain to full. It's absolutely lousy. Oh, we've got no earth, have we? We've got no earth. We're not. Oh no, we're on the external area. We're on the external speaker instead of the. So we're getting no reading. Earth on that. I'll connect the earth to one of the transmit coils. That's not reading right at all. Check we haven't got something gone wrong with the amplifier over the last 2 hours. I'll just switch it to public address. Testing 1 2, testing 1 2, testing 1 2, testing 1 2. That's absolutely fine. Back to CB. So at full whack, we've only got S5 coming through. It's so rubbish. So it's not deaf. It's like the detector's out, or there's something happened. I'll just give it a quick tap underneath. In case there's a dry joint. I wonder if somebody's messed the detector up. Sounds like it, doesn't it? Let's go over to the oscilloscope. I can't take any SINAD readings, you see, until this is actually receiving. Absolutely miles out. Wow. We've still got no. We've only got. We can't get anything on the meter, but at least we've got some volume now. I can't do it before the receive. I've knocked that off. The receive sensitivity. Can we get a reading? Oh, we can. We can. We can now. I've done the detector, but there was nothing before. It's 1.85 microvolts for 10 dB. I'm not even showing you it, am I? It's 1.7. And if it does 20, actually it does. Surprise, surprise. It's 567.5 microvolts. Full squelch is 300 millivolts. Nothing on there. Let's do squelch. That one's cleaning. Turn it down. Switch the signal generator to standby. Set the squelch to threshold. Surprisingly, it's 1.3. must do this banking. I'll just do the switch clean on the squelch control. If that wants it, the others will probably want it. I think it's been in a smoking environment now. I don't like to do this willy-nilly because it chases out the lubricant. Right, back with you again. Oh, I've gone and left the soldering iron on, that was silly. So why was this radio... Well, that had been screwed down, hadn't it? I think we have to release the squelch. It is open. So, see if we can do something with this IF. I think they've screwed up. So I'm looking at the oscilloscope, the SINAD meter and the front panel meter at the same time, and we'll see whether they've messed with this here. Oh, drops tool on the floor. We use the bigger one for that. Drop the signal. So I've now got a peak on that one. Let's do the same with this. I've got hiccups. Tiny little bit on that. This one. That one was spot on. So now it's front end time. Put less signal on. Go back to the detector in case it's in a false point. Going to go all the way out. Yeah, that's the point, alright. Well, it does sound normal now, but we've got no fairy lights other than one. Something's happening with the RF gain control. Switch it back on again. It's having no effect. See if we can get the fairy lights to respond. We can, but it's like at full whack, which you wouldn't expect. The receiver's working fine. We can get a new SINAD figure. Especially if we can get the squelch back in. Ah! look, it's the CBPA switch, which is dirty. Well, would you? I've never had that before. So with the set off, I've done the service cell switch cleaner. Switch it back on. Yeah, so you see we've got a dirty RF gain control. We've got a dirty PACB switch. So no wonder it was causing a headache. Right, we'll go back from the extension speaker to the test equipment speaker, and we'll just finish off where we were. I need my earth on there. Right, we're just going to do a final recheck of the detector. Make sure we've got 100 microvolts on. That's the peak, alright. Cracking receive like a lot of these early ones are. So let's go to the, I'll show you the SINAD meter. So I've got 12 dB on there. I've got 0.31 microvolts. .23 microvolts. 0.78 microvolts. We've calibrated that. See if we can set the squelch up. So, squelch to full. Let's see if we can squelch out. I've put the attenuator, I'll show you that. Put the attenuator to, let's move that camera down. 30 microvolts. See if we can squelch that out. Now we'll go to 100 and hope it opens. It does. Now we'll do the opposite. We'll turn the squelch right down to minimum. Out of interest, while we're doing that, I've got the signal generator on 0.3. Let's see whether we can hear it down to. About 0.12 we can hear it down to. It's fantastic. Right, signal generator to standby, squelch to threshold. Signal generator straight in at 0.3. I'm going to do that again. Yep. So we've got 100 microvolt on full, 0.3 microvolts there. So out of interest, I wonder if Roger Bleep works. It does. If you want to. Excellent. Well, that's worked out really nice. I've never had that before. That really did confuse me for a moment. Now, just these transistors I want to discuss before we put it back together. The transistor fitted normally is the Mitsubishi 2SC2166, which I was saying earlier was discontinued in 2001 by Mitsubishi, and you know, you expect to pay £16 for a real one. The 78 pence ones off AliExpress and that are fake. They're re-engraved audio transistors, probably even fall out at that. So what it says, at 12 volts up to 6 watts at 27 megs. Well, the way the circuitry is designed, it's not being thrashed, and they haven't got the kind of heat sinking. And the person who thinks that if you solder up that bit, he does exactly the opposite, because you've then got no flow of air. You know, they didn't get it wrong on the design, I can assure you. So it says, application 3 to 4 watts output power amplifiers in HF band mobile radios, 27 megs. That's what it is, 12 volts. Now when we move to the Sanyo 2SC 2078, you can see that we've got a very similar kind of thing. It's up to 10 watts, so theoretically it could be more powerful, but it isn't. It's not. It's aimed at 13.8 volt circuitry. I don't know how I can show you that quickly, but there's no reason, you know, that it's inferior, but it's just not what was original. We've got no spurious emissions or anything, so that's fair enough. So I did look at the graphs before I printed these off, and it's expected to be doing 4 watts. So there you go, and that's of course what it does. There's all these graphs here which are different output to different voltages and so on. So there you go. We've got the power output, which is what we wanted. I'm going to go over this with a bit of isopropyl alcohol, just around that where somebody's changed that transistor in the past. There's no dry joints or anything. There's quite a bit of leeway still on the crystal, and it's a very pleasing end. We're going to look under that tape. Curiosity. Just in case it's not soldered. Put a piece of heat shrink tubing in. This set is absolutely immaculate. It's a shame it's had a few bits of silliness. No, it's not been soldered, so that isn't ideal. Right, so we've parted that. We want a bit of heat shrink tubing. I used to work with somebody called Andrew who could only say heat stink tubing. Okay, we'll just solder that up. I'll put some heat shrink tubing down the wire. There's a sharp bit just there, there could be. Did I bring the heat gun? No, I didn't. We'll use the soldering iron then. I'll just do another precautionary thing, and that's these. Still got that to do, haven't I? We'll turn it off, let the power supply. There's not much to deal with here, so it won't take long to dry. So that's where they've changed the transistor. that's where I've seen a bit coming away from the chassis. I've changed the thingy, there's a bit there. Oh, I sent that Midland 77104 back and forgot to put all the case screws in it. Whoops. Right, well that's going to cheer up the customer. Yeah, we often just put 2 case screws in sets, and I put 6 out of his 8 in, and I thought, oh, I'll just put another couple of case screws, and I forgot, sent that back. So somebody is going to get a radio with 2 case screws missing. Right, let's power this back up, and instead of being on the test equipment, we'll put it on the roof aerial. I'll just clean that aerial socket, just make sure the leaves, the springy leaves, aren't sprained, otherwise Mr. Chippy will get to scratchy corner and he'll say to me, are you sure that aerial's connected properly? Right, roof aerial. Let's see if there's any bad buddies out there. One and a Roger.
Buy a bag of that kebab meat from Iceland. Why don't you just buy that kebab meat from Iceland?
Well, it's not often we hear anybody, is it? There we go. So thanks for watching. Sorting out an Amstrad 901 original Japanese real Cybernet version, which is one we're going to be selling. So thanks for watching the Amstrad 901 from 1981.